Hey guys, welcome back and welcome to Introduction to Coding. So the agenda for today is we're going to understand how computers work and learn basic computer programming concepts such as variables and syntax. We're going to gain an appreciation of various programming languages and study what they can do. We're going to develop a resource list of computer programming tutorials and tools, and we're going to become inspired to learn programming basics to help you work smarter and more efficiently. So, is coding a cryptic visual of typed languages or a process? Or is it both? Well, the answer is computer programming has a reputation of being cryptic and too complex for the average person. However, when you get familiar with basic programming logic, you will see patterns everywhere. So what is computer programming? Well, it is a set of commands a computer understands, kind of like a recipe. Computer programs can help cure diseases, drive cars, create video games, make animated movies, graphics, build websites and apps, and much more. Basic coding concepts are used by most everyday programs and most every programmer. So why learn code? Well, the first question is why not? Learn the importance of clarity, brevity of expression. You're going to be able to think and problem solve more accurately. You're going to have a better understanding of how technology works, and you're going to be able to create a tool that can make your life and many other lives easier. So the STEM problem, science, technology, engineering, and mathematics, is in computer science. So 67% of all new jobs in STEM are in computing. 10% of all STEM graduates are in computer science. So what is a programming language? So a programming language is a set of rules that provides a way of telling a computer what operations to perform, communicating an algorithm, and receives an input from the user and generates an output. A programming language is a system for describing a computation or math or algorithms logic in a machine-readable and human-readable form. It has words, symbols, or grammatical rules like natural language. Grammatical rules equal syntax, and each language has a different set of syntax rules. And it has semantics or meaning. So a few basic programming components, pretty much regardless of language. So if we're talking about block language, if we're talking about Python, if we're talking about C++, Ruby, if we're talking about any programming language that you can think about, it's going to have these same components: variables and arrays, operators, flow control, and functions. So variables and arrays, it's a bucket that holds one piece of information. A variable can change value when specific conditions are met, and it's based on user input. So examples would be a concept. And so you can look at some of these examples. So concepts such as a place, Montgomery Library, a variable or a value such as 100, or a name such as Brian. Here's some examples of variables using block language. And so you can see that they each have a piece of information, right? So it's set variable to a value, change variable to a number, change variable, hide variable, and then if you look at the bottom, there's lists, numbers, items, blanks, and conditions. So if we look at this right here, for each item in blank, plug and play equals add thing to blank, delete one of equals. And so the way that this block language works is that you're going to use these variables to denote some type of information that you want your script to do. So operators. Operators are arithmetic, such as addition, subtraction, multiplication, divisions. Assignment So assigning value to a variable and adding value to a variable that holds already a place value. So here's some examples of operators. So you can see when we're using block language, no matter if we're using snap or if we're using scratch, the operators are going to be green. The variables are going to be orange. You're noticing a color similarity. And so the operators are always going to have some type of value assignment, right? They're always going to have some type of number assignment when you're talking about operators. And so what type of values would be using for operators? So game scores would be using operators. We'd also use operators when we're talking about number of lives in games. So flow control is the sequence. It reads like a book. The instructions are executed in the same order they're given. So example, open the door, walk inside the room, sit on a chair, pick up a book, and read the book. So when you look at flow control, they're going to be in blue when we're looking at block language using snap or scratch. And it's always going to be talking about a set of instructions, something that you want that script or that sprite to do when you're designing your game or your program. Flow control choice. So control, we have flow control motion, which is blue, and we have flow control choice, which is going to be yellow. So it's a if-then sequence. If something is true, conditions are met, then do this. If then else, right? So if something has a false value, then do this. So it's all condition based, and it's all controlling the game or the program. So examples would be when the green flag is clicked, start the game. When the space key is pressed, then fire a missile, right? And so it's going to be controlling some type of action within your game or your program. So putting it together. So number one is sequence, right? Go to the library, check out a book, read the book, return the book. Number two is choice, right? If you have a library card, then you can check out books. Otherwise, open a library card account. And then number three is the repeat. So you continue to read the book until there's no more pages. Functions. So a function is a type of procedure or routine and usually returns a value. A procedure performs an operation but typically doesn't provide a value. So most languages have a pre-built or predefined function in its library. For instance, the delete function means to remove. You don't have to code what remove does, only what to remove. So defining a function in Python, you can see it's a little bit more complex. And that's what the good thing about Snap is, the program Snap, is that as we are coding in this block language, we can convert it to Python. The same thing in Scratch. And so when we're looking at this example here, there are certain functions that you have to type in order to have operations met. The other type of programming language that we're going to be using Python is when we program or code Arduinos. And so it is a little bit more complex, but we'll get into it. So, what do you want to make? Well, if you want to develop games, right? So that's where you're going to be developing on online, mobile, or other game platforms. Where do you want to work? Well, you're going to be working in computer game businesses, game publishers. The languages that you're going to have to know are C, C++, C, hashtag, and then Java. JavaScript also. Other skills, you're going to have to have design capabilities. You're going to have some type of 2D or 3D modeling ability, whether you're using a program called Blender, Photoshop, Adobe AutoCAD, 3D SolidWorks. So you work well under pressure and you have a knack for problem solving. Things that you probably like to do outside of work, you can see shopping online for classic Nintendo games. Just some examples, guys. So the mobile app developer. So what do you want to create? Well, you're creating apps for mobile devices, primarily iPhone and Android. Apps such as banking apps, Netflix apps, social media apps, news apps, right? So your languages that you're going to have to know are Objective-C and Java, and then you can see the other skills and things that you may like to do outside of work. So as we're going along, if you want to read more about some of these different jobs, just press pause on the video. So the web developer, you create applications that run entirely in browser, such as websites. We've been doing a little bit of website design lately. E-commerce websites such as Amazon, eBay, and Etsy. Social media websites, educational websites, and then search engines. You can see the list of languages that a website developer needs. C+, you have also Java, PHP, SQL's the Ruby, Python, and then JavaScript. And then you can read where you would work, other skills and things that you might like to do outside of work. Next, you have the software developer. So you're developing operating systems such as Microsoft Office, Quicken, or iTunes. You can see the languages, C, C++, Java, SQL, and Python. So you're seeing a commonality here, right? So Java, C, C++, Python, and SQL are on a variety of required languages to learn. And then you can read the other skills and things that those software developers might like. Okay, so now we're going to talk a little bit about the different programs or different sites that we're going to be using this year. So the first one that we're going to be starting off with is Snap. And so Snap is, like I said, block language. It's based on Python, so once you code it, you can go back and you can look at the Python code that's underneath each block. And it works in two ways. One, it gets you to understand all of those blocks, all of those functions, right? And it also, once you develop the game, it gets you used to using logic, how to move things, how to code in order for your game to do certain actions. So that's what we're going to start with. Then we're going to go into Scratch. In Scratch, we're going to be coding a Mars rover game. And so we're not going to be going into too much basics of the Scratch, but we are going to start with Scratch as another platform. Some of the students here in class may get into Lego Mindstorm with the EV3, a little bit of robotic coding. And then we'll be going into Arduino Simulator and programming. And so this is using, again, Python language. And so this is a microprocessor. We're going to be using an online program to program the microprocessor, and then in-person students would be actually uploading that information into a microprocessor and testing their code. And so here's some examples. So we have the real-time simulations, we have Arduino programming, and then we have starter examples. So this is what we're going to be doing. So prototyping electronic designs, programming Arduinos, and then learning electronics by tinkering with ready-made examples. And then finally, we're going to be going into a program for apps, and we're going to be creating some apps using the MIT App Inventor. And so with this program right here, we're going to be actually programming a couple of apps that could be used on phones. And so this concludes our introduction to coding, just kind of giving you a general overview about what we're going to be doing, some of the coding types, right? And the different types of functions. So what I want you guys to do is now make sure you understand those types of functions. And if you have questions, please ask your instructor. Have a great day.